All right, so we are looking at worksheet 7. The front of worksheet 7 is notes. The back will be homework, but we're going to get through as much of it as we can, so your homework load is a little less. Reminder, the 4.4 to 4.6 expires tomorrow. Just don't forget about that. Yes, ma'am. After school today. Mondays after school is SAT tutoring. Thank you for the reminder. Up until SAT day, yep. You don't have school that Monday, so I guess before your Easter weekend, yeah. Yeah, you have long Easter weekends. You get like Friday off and Monday off, and then you come right back to SAT testing on Tuesday.
And then Saturday's ground.
Wow.
No way.
That's crazy. All right. That sure is.
I don't think I like that.
It's okay, but then you're almost done. Because in my head, as soon as I get to April, like, game on. The end is in sight.
Yeah, that's what AP takes.
I mean, okay, let me rephrase that. Your teachers are done. Yeah. I'm done. So, you know. You know, I'll make sure I give you a big packet and then I'll tap out. Yeah. How fun for you. You could do that this week.
Definitely not. It's got like 3 practice AP tests in there.
All right. So there's some new identities we have to talk about today. They are all on your blue formula card, so make sure you have that handy. Not all of them are on your notes page because we've forgot to clip a section. So be looking at the blue card. The first chunk that I want you to look at are called the double angle identities. And there's 3 that you need to notate. There's sine of 2 theta. There's various methods for cosine of 2 theta. And then there's tangent of 2 theta. We'll come back to that in a minute. So we asked Mrs. Gupta which one is like the most important one for kids to know and that they have to use a lot in calculus. And she said the double angle for sine is the one that's used the most often. So sine of 2 theta is 2 times the sine times the cosine. Seems easy enough. Now cosine of 2 theta, because of the way it's derived, there's 1, 2, 3 different ways you could trade it out. And sometimes it just does not matter which one you use. Like today I'll ask you, we're going to simplify and evaluate. I don't care which one you choose. Top one's my personal favorite though. But then when it comes to equation solving, maybe it totally matters which one you trade out. You want to think ahead. Do I want cosines and sines? Do I just want cosines? Do I just want sines? So you got to look at the rest of the problem to figure out that. Tangent has its own formula, but what we'll find out in our practice is that often these questions come in 3s. It'll have you find the sine of 2 theta, and then the cosine of 2 theta, and then it'll ask you for the tangent of 2 theta. So rather than using this identity, y'all know that tangent is sine over cosine. So if you already have sine of 2 theta and cosine of 2 theta, you could just divide them and get tangent of 2 theta. And that's what we're going to see quite a bit today. So here, this is an example out of your textbook where they did exactly that. So the first thing they gave you was some clue.
Can you back up?
I can.
Why wouldn't that equal just tangent?
It's tangent of 2 theta.
Why?
Because inside of the sine function and the cosine function, you have the same angle of 2 theta. So he would be the tangent of 2 theta. Because theta represents, like, I'm just making this up, 43 degrees. So if theta is 43 degrees, then 2 theta would be 86 degrees. So you're finding the tangent of 86 degrees in that case, not 43. All right, so here out of your book, they'd give you a clue. They'd say sine of some mystery angle is negative. There's a negative right here, 7 over 25. And it's on the interval pi to 3 pi over 2. So they went ahead and drew a little triangle in quadrant 3. Is that the right spot? I mean, it better be. It's from your textbook. But the thing they didn't do, though, which I do, even though it's wrong, I like to label the legs negatively. Because you know what happens. You lose negatives in your work later on if you don't do that. They used Pythagorean theorem to find this other leg to be a 24. However, it is a Pythagorean triple. 7, 24, 25 is a triple. So then, the first question they had for you is, what is sine of 2 theta? Now, they did not tell you the angle measurement, and without technology, I wouldn't be able to figure it out without estimating it, perhaps. But for the sake of argument, can you guys just assume that this is about 200 degrees? Okay.
Sure.
So if I doubled 200 degrees, where about am I? I'm at 400 degrees. What quadrant is that?
1.
Yeah, it's over here.
Which is
Ish. Now, everything I come up with in the next 3 problems better be positive in sign. Because in first quadrant, isn't everything positive? And the math is going to magically work out that way. So that's a good double check for everybody as you're doing these questions. So for sine of 2 theta, they used this identity we just learned today, where it says 2 times the sine times the cosine. And this is, I think, the hardest thing for kids to understand because there's just so much trig going on in your brain right now. The sine of theta is the ratio -7/25. It's the expressed ratio from the legs of the triangle, okay? The cosine of theta is -24/25. So 2 is part of the formula, times this, pop that in your calculator and you get the glorious ratio of 336/625. Yes, I was just about to guess that. So then cosine of 2 theta, this is where they had to make a choice, and they went with 2 cosine squared minus 1. That was silly of them. I would have gone with cosine squared minus sine squared myself, but whatever. It doesn't matter because it's going to work out. So right here, the 2 was part of the formula, but the cosine ratio was -24/25. The formula says to square that ratio and then subtract a 1. I have a feeling whoever did this problem just cranked that whole thing in their calculator, hit math, enter, enter, and came out with 527/625. Yeah, I know, right? And then to find tangent of 2 theta, well, you got a choice. You can either use the tangent formula I give you on the card, and it will work out. Or, since you already had sine of 2 theta and cosine of 2 theta, you could have just divided sine divided by cosine, which gives you that. Either way, you get the same answer, so it doesn't matter your method of choice. So there's a little bit of freedom in these questions, which is sometimes dangerous. So the double angle identities, those are on the top of your notes, but like I said, keep referring back to your blue card because that's what you get to use on the test. Let's take a look at this question. It's kind of sort of done for you. First of all, I noticed I have a drawing, but y'all don't. So give yourself a little drawing. It says we're on the interval from 0 to 90 degrees, so that's why I'm drawing a triangle over here in the first quadrant. And then the other clue is that the sine of theta is 1/4. So if I set up my legs of my triangle to have a sine ratio of 1/4, that would be vertical leg is 1, hypotenuse is a 4. And then they've already done this part for me, but apparently this missing leg is the square root of 15 because they did some Pythagorean theorem, right? They said 4 squared equals 1 squared minus x squared, plus x squared, excuse me. They subtracted that over and square rooted. All right, so now you got to think about what do they want. They want just double angle for sine, I think. So this is a case where they don't want you to find everything, just one. What quadrant would I be in if I doubled this angle? Like, give yourself what you think is an appropriate angle measure and double it. Like 40 degrees-ish? 40 degrees doubled. 80. So, like, I'm here, I think. I mean, I kind of estimated. I don't really know. Worst case scenario is I'm over here. Either way, I'm finding the sine. And what do you know about sine ratios in either one of these quadrants? They're going to be positive. So the math is going to work out. You don't have to like indicate signage. It's a good double check as you're doing these problems. So 2 times the sine of the angle times the cosine of the original angle. So this is where I want you to maybe highlight some things for yourself. The sine of theta is the ratio 1/4. They replaced that with a ratio. The cosine of theta is the ratio square root of 15/4. This would not be a good one to crank in your calculator because it's irrational. So they just kind of smush everything together. And in the numerator, you technically had 2 square roots of 15. And then in the denominator, you had a 6/16. The 2/16 reduces to a 1/8. And that's how they got that formula right there. Or that ratio right there. So we're finding things about angles that we really don't know anything about. And we have to use our identities to get them because they want exact answers. All right, so this one, I believe is not done for you at all, but spoiler alert, it's in the third quadrant. How'd I know that? Because it says right here, it's between pi and 3π/2. So, knowing me, I've drawn a not drawn to scale triangle, but sorry. The other clue they give you is that your tangent ratio is 4/3. So, I get a lot of kids writing this out, which is technically accurate, but what are they more than likely going to forget? Yeah, this is a negative movement on both of those ends. Now you could do Pythagorean theorem, or maybe you recognize that this is a 3, 4, 5. And now I'm going to be able to figure out whatever they want me to figure out. And turns out they want me to figure out everything. So we're going to start with sine of 2 theta. So our new formula that we just learned today for sine of double angle is 2 times the sine ratio times the cosine ratio. So this original triangle, Oh, and you know what? I didn't ask you guys this, but do you know where we're going to land if we double this angle? So,
In the front quadrant.
I don't know about that, because this angle, like all the way down to here, it's like 200 and, I'm kind of making this up, but like 240 degrees-ish.
So maybe in the second quadrant.
I think we're going to end up in the second quadrant if we double this.
So we take it from like.
From standard position, yes. That's why it's kind of hard for kids to visualize. And like I said, the math will work out on these, but if you were the kid who drops negatives in your formula, like when you set up your triangle, think about where you're going to be. You're going to be in quadrant 2. So sine should be positive over here, but everybody else should be negative. So keep that in mind. So the sine ratio in this original triangle was what? Negative 4 over 5? And the cosine ratio for that original triangle was negative 3 over 5. So see the math working out to a positive value here. You end up with 24 over 25. Now, they want me to find the cosine of 2 theta. So I leave it up to you guys. Which formula do you want to use? Because there's 3 of them. The first one is cosine squared minus sine squared. The other one's, do you like that one? Okay, me too. So the first one says cosine squared minus sine squared. It has to go in that order, so be careful. So the cosine ratio for this original triangle was negative 3 over 5. It's going to be squared. This subtraction sign does not get squared, so keep that there. And then we're going to square the sine ratio, which is negative 4 over 5. So this ends up being, let's see here, 9/25. Subtract 16 over 25. And we end up with a negative 7 over 25. Now, does that make sense for what quadrant we'd be landing in?
Yes.
The cosine that's negative in quadrant 2. Yeah, makes sense. All right. So then the third one they want you to find is tangent of 2 theta. So it is up to you guys. Do you want to use the trade that they have on your blue sheet? Or do you want to just use the sine and cosine ratio that you've already computed? Yeah. Okay, so you are living a little dangerously doing this by using the sine and cosine you just found. Because, yeah, if you got them wrong, then like whoopsies. Instead of dividing by the cosine, I'm going to multiply by the reciprocal. Just make sure you don't lose your negative in here somewhere. 25s will knock out, and you get a negative 24 over 7. So I just got a negative tangent ratio in the second quadrant. Make sense? Awesome. And all those should kind of go together in your brain. Can you envision a triangle with legs of 7, 24, and 25? Yes, because that's actually like a Pythagorean triple, isn't it? Oh, magical, huh? No, they're not always pretty. Like the one we did before was square root of 15. Like, had I done all 3 of them, we would have seen the same 3 numbers popping up in the ratios, but like they're kind of icky, so that's okay. All right, so now we have these new identities that we can use to solve. Okay, let me show you something here. I got sine of 2 theta minus sine equals 0. This is our original problem. This is out of your textbook. And they just want me to find all my solutions between 0 and 2 pi. So a lot of kids are looking at that thinking they're supposed to factor a sine function out, which I think is a great instinct that you have. However, these are not the same function. This is sine of 2 theta and this is sine of theta. They are not the same thing. So you cannot factor right now. Instead, what they want you to do is they want you to trade. They want you to take sine of 2 theta and they want you to trade it away for this guy. Now you have all the same types of functions. Sine of theta, cosine of theta, sine of theta. Now it's a great factoring question. You can, and some of us learned this very valuable lesson again on our test last week. When you have a function, you cannot divide by it, but you can factor it out of the problem. Okay? You can never divide by variables or functions because you lose half of your solutions. So now that we set them equal to 0, we can go through and solve and find all of our solutions. It was a good time. So 0 and pi over 3 and 5 pi over 3. So once we did that new trade, it really looked like a question that belongs on last week's test. Good news, you get another chance to redeem yourselves about how to solve equations. Unfortunately, it's not the same score. It's not a 5.3 score. It'll be within these sections, 5.5. All right, the power reducing identities, it's not a pink reference sheet for you guys, it's blue. They are on there. Turns out we actually aren't going to use them. Yeah, I mean, I could show you an example. They're not awful, but we just don't have a need for them. And actually, they're very infrequently referred to in calculus. But you can imagine it might be handy to be able to take something that was squared and switch it out for something that's no longer squared. I mean, you're taking away a whole level of like quadraticness to the problem, which is kind of nice. Turns out I don't really care about them, so I'm going to move on. All right, so let's take a look at this one. Cosine squared x minus cosine 2x. I want you to plan ahead for a trade, because there's a question. I don't think this is on your paper anywhere, but you guys might want to write this one down, because this is very much like one that's on your homework and also on your test. Since I'm not going to mess with the power reducing identities with you guys today, that means if I'm trading anything, I'm trading this. Cosine is the weird one where you got like 3 things you could possibly trade it for. Look at all your options. You got cosine squared minus sine squared. You've got, I always forget the middle one, 1 minus 2 sine squared, and then you have 2 cosine squared minus 1. Look at the rest of the problem. All I have to work with is a cosine squared function. So wouldn't it be smart if I used that last trade? Because then I'd have all cosine squares and that's it. So I'm going to trade this guy out for the 2 cosine squared minus 1. They want me to use x's, by the way, instead of thetas. Everything else in the equation has stayed the same, including this negative that you have to distribute. Speaking of that, let's do that. So distribute, and you end up with cosine squared x minus 2 cosine squared x. This negative 1 becomes a positive 1 because of the negative. And I know some of us are a little panicky from the last test. You're like, oh gosh, how do I solve this? And your first instinct is probably factoring, which I'm not going to say is wrong. However, I noticed that this really belongs in the realm of square rooting. There's only one type of function in this whole problem, and it's a cosine squared. Like, there's no individual cosines out there. So I think this is a good candidate for square rooting, which means I'm going to collect these together, and I'm going to subtract 1 over. So I end up with negative 1 times the cosine squared of x equals negative 1/2. Because there's like a 1 minus 1 here. Minus 2 here. I just added these together.
Oh.
Now, I don't like that there's a negative 1 in front. That feels like I need to knock it out as a coefficient. So either divide everything by a negative 1, or you could think of it as multiplying everything by a negative 1. Either way, it's gone. And now I have cosine squared x equals 1/2, which brings me to another problem some of you ran into on your test last week. Our next step in this square rooting problem is to square root. Let your algebra brain kick in. What do you remember about square rooting equations?
Plus or minus.
You need a plus or minus right here. So that error analysis question on your test last week, the error the kid made before anything else happened was they didn't put a plus or minus on their radical solutions. And therefore they left off like a whole bunch of solutions. So this is 1 over square root of 2. But guys, what happens when you rationalize that? Square root of 2 over 2. So y'all are looking in the pi over 4 families. So your solutions are at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Those were all the solutions I was looking for. So that was fun. It's coming back on your next test. Not that section, not 5.3, but the skill of solving an equation is coming back in your next test. Yay. All right, so these are on your formula sheet, but they're not in your notes. So if you wanted to write these on your notes, you can, but I don't think any of you are going to dig out your notes when it comes to like looking up formulas. You're probably just going to pull your formula sheet. What I want you to recognize, though, about these half-angle identities is that these plus or minuses in front, they're not saying the answer is both positive or negative. They're saying that you need to think and choose positive or negative. So you have to think about what quadrant are you in, and should I have a positive sign or a negative sign in that quadrant. So it's not the answer is plus and minus all this mess. You have to actually make a thought. This is not usually how plus or minus works in our formulas, is it? All right. So that's this little blurb from your book. You have to determine your sign. Check the quadrant in which theta over 2 lies, not theta. So that's a little confusing for kids because they're like, wait, what? So this question is already going to mess with some of you because you're like, 22.5, that's a very strange and unique number. Well, isn't that 45 cut in half? So knowing that the formula we just looked at was the half-angle identity formula, there we go. So in this case, theta is 45 degrees. Theta over 2 is 22.5 degrees. Now, you don't have to do a lot of thinking here, guys. What is the sine of a sine function at 22.5? Positive or negative? Positive. So it's not plus or minus in front of this weird funky thing. It's just positive. Square root of, and I never remember these, so I got to look them up every time. The formula is 1 minus the cosine of theta over 2. So, positive, which you don't have to write. 1 minus, well, the cosine of theta, remember we just determined that theta is 45 degrees. So what is the cosine of 45 degrees? Oh, gross. Square root of 2 over 2. And then all of that is being divided by a 2. So, I'm okay if you guys stop here. This actually isn't on the formula. This isn't on your homework or your test. So, like, I just want you to be able to recognize the pattern and plug stuff in. What they probably want you to do in your book, though, is look at this numerator and get common denominators. So they'd call it, you don't have to write this down, they'd call this like 2 over 2, right? So they'd be like 2 minus the square root of 2 over 2. And then it's divided by 2, so they can multiply that by a 1/2 instead. So then it becomes the square root of 2 minus square root of 2 over 4. And then your book would say, well, the numerator is really gross, but the denominator, if you square root of 4, you get a 2. So then your book might say this is the answer, where 2 is out of the radical now as a denominator. And to me, I'm not really sure that that's any simpler, is my issue. So I don't really know if it was worth that. So I'm just going to say for you guys, stop there. If it's got funky radicals within radicals, like, don't do any more simplifying. The questions that we're going to be doing on worksheet 7b work out really nice, where they're rational numbers. So those we can simplify. But if it's already got a radical within a radical, like, stop your work and don't do any more. Let's take a look at this guy. Oh, guys, I can't think about radians. It's Monday. Can someone convert that for me? Yeah, you got to multiply by 180 over pi. 165 degrees? Cool. That is not on my unit circle, but I bet he's somebody cut in half. What's 165? Is it 330 cut in half? Probably. So what we have here is really 330 cut in half. So what that tells me is that this guy, this is my theta. Now, let's talk about sines for a moment. What is the sine of a cosine at 165 degrees? It would be like right here. Positive or negative? Cosine in the second quadrant. Negative. So I'm going to stick a negative sign in front of this ugly radical thing. And now I look up my formula because I never remember it. This time it's 1 plus cosine over 2. So the cosine they're referring to is the cosine of 330. So keep the negative in front. I got 1 plus, what is the cosine at 330? Yeah, that's positive square root of 3 over 2. And then it's being all that divided by 2, all of that within the radical. And your math teacher says, please stop here. We got a radical within a radical with denominators within denominators. Like, no thanks. I'm not messing with that, guys. There's really, whatever they think looks prettier, it's not prettier. Sorry. It just kind of hurts your brain, that's all. I can go through and tell you what the book wants you to have, but if you guys don't care, then I'm okay moving on. Seems like you didn't care. It's okay. No judgment. This is a use of the half angle within an equation. I'm not saying, like, you'll never use it in your life, but not on my test, so... they took this cosine of x over 2 and they swapped it out for this 1 plus cosine over 2 square rooted business. Now, because the function was squared to begin with, they squared away the radical and everything kind of magically worked out beautifully, so that was nice, but that's more elaborate than what I'm going to have you do. This is on your notes. Let's all do this one together. So with fresh eyes here, we got a cosine theta times sine 2 theta equals 0. And I want all your solutions between 0 and 2 pi. There would be absolutely nothing wrong with a kid saying, hey, I'm going to factor this. Like it's already factored technically, right? You have a multiplication problem, so they set this and this equal to 0. Well, I think you're still going to run into a problem with this. Because if you set sine of 2 theta equal to 0, this is a U substitution problem from last week. Did you enjoy those? Did you enjoy them when you had to find 0 to 2 pi answers? Even less so. So why don't we try some of our new trading and maybe we'll have less work, and I think we're all on board for less work today. So let's trade. Instead of doing this business, let's trade. Sine of 2 theta. Who's your trade for today for sine of 2 theta? Yeah. 2 sine theta times cosine theta. Everything else is staying the same in the equation. So in front you got a times cosine theta and then it still equals 0. And this is kind of hard to understand because it looks like it should be way more complicated, but this is just a giant multiplication question. So first thing I notice is you have a coefficient of 2 that I would like to get out of there because it doesn't do anything to the problem, so I'm just knocking it out by dividing. Since 2 is a coefficient, not a variable, not a function, I can do that. So now, if you wanted to, you can join up the cosines and call it cosine squared times sine equals 0. All right, kids, it's time to set them equal to 0. Each one of these set equal to 0. So cosine squared equals 0. That's boring. Sine squared equals 0. That's boring. Normally, I'd have you square root both sides, and guess what happens? Cosine still equals 0. All right, guys, I'm ready to look at your unit circle. Tell me every single place where either your cosine or your sine come out to 0. And you should be listing all of my quadrantial angles.
0.
Yes.
Pi over 2.
Yes, I can't erase. Hold on. 0, pi over 2,
Pi.
pi,
2 pi over 2.
and 3 pi over 2. Notice what Taylor did not tell me. She did not tell me 2 pi, which was correct, that she didn't tell me 2 pi. Why would it be wrong if someone told me 2 pi? Because it says parenthesis, meaning non-inclusive on the endpoint of 2 pi. So I like that she called that angle 0 radians as opposed to 2 pi radians. I would have to be really mean and picky if she told me 2 pi. Sorry. So that officially ends the notes, but let's do some work together and that'll be like continuing the fun. All right, we got 15 minutes. How much do you think we can do?
3. Oh, that's we. What?
I think we can do all of it.
Uh-huh.
But I'm a positive person. So here we go. So I've drawn a triangle over here. You guys might want to do the same thing. It says we're between pi and 3 pi over 2. So are we in the right quadrant?
Yeah.
Cool, cool. All right, so the only clue they gave you is that the sign of alpha, that's an alpha symbol, is negative 3 over 5. So I do that illegal thing where I call my legs negative, even though I know they're secretly not. What about this missing leg?
4.
It's a 4, but because it's left,
Negative.
it's a negative 4. Now, again, I don't really know what quadrant we're going to land in. I have to kind of make some assumptions. This is, if I measure from standard position, anyone have an estimation for that angle? Now, again, the triangle's not drawn to scale, so I'm misleading you already. Yeah, we're going to end up in, so like right now it's, just throw an angle measurement out to me that kind of makes sense to you to be over here.
Like 200.
To 100? 200? Okay. And if you doubled that, because we're going to do a bunch of doubling,
400.
we'd be at 400. Which, I don't know if that's true. Because 400 would be in quadrant 1. What if someone was a little more ambitious about this and said, you know what, I think this is actually at, like, more towards the middle of the quadrant, which would be more like, I can't add all of a sudden. Hold on, it's going to come to me. 225-ish? It's not, by the way, but let's just say 220-ish. If you doubled that, it'd be at 440. Should be at 120. So we're somewhere. That's helpful. We're either in quadrant 1 or 2. We're about to find out what quadrant we're in. Now, let me show you a little sneak attack. You can actually figure out exactly how big this angle is. If you pretended this was in the first quadrant. Actually, just solve this for me. If you were on your calculator, can you put your hello, calculator. Can you put your calculator in degree mode real briefly?
Yes.
Can you inverse sine Not negative 3/5, but 3/5 for me. Just inverse sine 3/5, because you'd have cousin triangles all over the place, right? It's 36-ish degrees off of 0, right? So if this is 36 degrees, that means this guy here is 36 degrees. So this is like 180 plus, let's just round to 40 degrees for fun. So we're looking at about 220 degrees. So this kid had a better estimator on him, but who cares? Because the math is going to work out brilliantly right now, guys, all right? So the sine of 2 theta, you got a trade for me today. What's sine of 2 theta trade out to? 2 sine times cosine. So for us, that means you're going to do 2 and then times 2 different fractions. Who's the sine? Let's start there. Negative 3/5. The ratio for sine for this triangle is negative 3/5. And then the cosine ratio would be, check your triangle out, negative 4/5, which means you just need to crank this guy in your calculator or think really hard. And that's what, positive 24 over 25? Which doesn't really help me if I was still wondering what quadrant I was in, but that's okay. Now cosine of 2 theta, you got a choice. What trade would you like to make for cosine of 2 theta? I like that first one, yeah. I like the way it looks. I like the way it sets up. I like the way it simplifies. So cosine squared minus sine squared is what we're setting up. Has to be in that order, so watch out. So cosine squared is a negative 4/5 squared. There's a subtraction sign between them. And then sine squared is a negative 3/5 squared. So that comes out to, let's see, that's 16/25 minus 9/25, which is 7/25.
Oh, no. Yeah.
Am I okay? Okay. I feel like I did something there, though. No? We're okay? My only concern is what quadrant we were in. Didn't we say we were, like, in quadrant 2? I guess we're in quadrant 1, yeah. Whatever. Did I screw up my order or something? No? Alright, whatever. All that song and dance for nothing. I don't know. What's 180 plus 36? Is that where I'm going wrong? I can't do simple addition?
16.
Yeah, I don't want an I think answer. That's where I'm at. 180 plus 216? Double that for me. You get 432. And then subtract 360 for me, and you get... That's in quadrant 1, Abruzzo. You crazy. Just making up numbers. Ah, never mind. Remember how I kept rounding randomly? I was like, 220-ish. Yeah, no. You can't really ish that. You have to actually do the math. Ugh, gosh, forget it. All right, now we have to find tangent. I already found sine and cosine, and I'm like 90% sure we did it right. So should we just use our sine and cosine?
Yeah.
So sine divided by cosine would be 24 over 25. Instead of dividing by cosine, I'm going to multiply by the reciprocal of cosine. And y'all get 24 over 7. Cool. All right. Well, now I'm afraid to even ask this question. Sine. Now we're going to half all of them. So you guys just told me, and I already forgot. We decided our original angle, what was it? 216 or something? If we have these at 216. 108. What quadrant are we in?
2.
We're in quadrant 2. So the sine is going to come out positive, but the cosine and the tangent are both going to be negative values. So remember, on the half angle problems, you do have to determine signage. It doesn't magically work out on its own. So I'm just going to quickly do that. I'm going to put down sine so I don't forget that. The sine for our half angle, we're still going to use the same triangle. Oh boy, here we go. Square root of, the sine formula is 1 minus cosine over 2, I believe. Can someone double check that for me?
1 minus, yeah.
Okay, so 1 minus cosine would be, careful, there's another negative here, negative 4/5. Yeesh, you can't read that. And then divide this whole thing by 2. Now, I don't know why my work is going wobbly like that. So now we don't have radicals anymore. Now we have nice rational numbers. 1 plus 4/5, that's something. What is 1 plus 4/5?
9/5.
Yes. You guys follow Taylor's math there? 5/5 plus 4/5? Okay. So you've got 9/5, and then divided by 2 is the same thing as multiplied by half. And all this mess is under a radical. So y'all, you got square root of 9/10. Now, I'm not going to be a gracious teacher and say you can leave this, because y'all are good at rationalizing things. If you were to square root the top and bottom here, you'd get 3 over square root of 10. And then if you rationalize that, you'd get 3 square root of 10 over 10. I did kind of skip a step there. If you need me to go back and show that, I will. Remember, we decided this was positive, so that's why I just made sure my answers had no sign in front, because that indicates positive. Now, the cosine formula for half angle looks very similar, but this time we determined it's got a negative in front of it, so keep that in mind. And you got a square root of 1 plus the cosine, so 1 plus negative 4/5. That says 4/5, and then divided by 2. So this, all right, don't fail me now, 4th grade math. 5/5 minus 4/5 is 1/5, right? So you got the square root of 1/5 divided by 2 is like a multiply by 1/2 again. Oops, I lost my negative though. Happens every time. So we got a negative square root of 1/10. Square root of 1 is beautiful, square root of 10 is icky. So after I simplify and rationalize, I get negative square root of 10/10. Well, that was just gorgeous. Okay, so now tangent. I'm kind of overusing these formulas. I don't really want to look at the tangent one. Can we just take sine and divide it by cosine and just live dangerously? So I know it's negative, but guess what? It's going to come out negative anyways, naturally, because of the way the work is set up. Sine, 3 square roots of 10/10. And then divided by cosine would be multiplying by the reciprocal of this guy. Remember, I already have the negative sign down there, so I'm not going to write it down again. See a lot of cancellation. This is kind of nice. The rationalization terms go away. And you end up with -3. Who would have thunk? Well, that was just great.
Wow.
Woo! And just like that, you're half done with your homework. That was the long question. The rest of them are really short. Now, the next section, first of all, there's a typo. I know they don't look short, but they are. This is a typo. This is supposed to say X right here. I don't know if we fixed it on your sheet or not. So this is not like Friday's homework where they want you to simplify it and verify an identity. This one, they just want you to find the trade and like condense it back together. So sine, cosine, cosine, sine, that's Friday. Who is that? Who's sine, cosine, plus cosine, sine? That's right, sine of A plus B. Internet, they knew that. So this condenses down to the sine of your A and B are pi over 2 and x. So they don't actually want you to do a lot of work there, guys. They just want you to smush it back together using the identity. So this is going to be a mishmash of Friday and today's identities, which is very similar to what we see on our test. So keep that in mind. This is a new guy. Cosine squared minus sine squared. Who is he? No, it's not one of our Pythagorean trades. This is one from today. Isn't this 2 theta for cosine? So I wrote over my problem, but wasn't the angle called beta? So when I smush this back together to look like this, it would be cosine of 2 beta. That's a beta symbol. Looks like a bee with a weird little tail. Capital beta.
What?
Beta. Yes. Tangent minus tangent over 1 plus tangent tangent. I didn't have a chant for you on Friday, but that is totally from Friday. Who is that? Yeah, that's A minus B. Yeah, tangent of A minus B. So my A and B are alpha and beta on this problem. So this smushes into the tangent of alpha minus beta. That's it. That's all they want here. Match up the trade and write it down. It's an alpha. The fish symbol is an alpha. Greek letters, man. Come on. All right. Now this one looks a lot like a question on your test, and kids get a little bamboozled by this one. 2 sine cosine. That's from today. Who is this? Oops, not that. It's double sine. Yep. It's sine 2 theta. So what you need to concentrate on, though, is who exactly is your angle inside of this problem? 3x. So if you smush that back into the condensed version of this identity, yes, if you double 3x, you get 6x. That one's really hard for kids because there's an algebraic and numeric component, so they're confused as to what I want, and that's what I want.
So when you decide to cosine, you do that.
Nope, that's it. So like the formula for sine of 2 theta is 2 times the sine times cosine of the single identity. So this is what we had, and we went back and made it look like that. Okay, so E is a little confusing because we don't know what alpha is, so they did put the plus or minus in front. It's fine, just go with it. You should be able to identify who this is, though. This is one of the new weird guys from today. Is this half cosine or half sine? Half cosine? So this right here, this is like the theta. So this smushes into cosine of theta over 2. So for us, that would be cosine of over 2, better known as
A over 2.
2. No, 2. You told me 4 alpha over 2 is what you were about to tell me, and then it reduces to 2 alpha. Oh, that's from Friday. Sine, cosine, minus cosine, sine.
A minus B
Sine of A minus B. Yep, this is sine of A minus B. Which is, oh, this one's fun. A minus B. In that particular order would be negative 10. However, there's a little note on my key that this is actually negative sine 10, I think is what they wanted me to simplify it to. Anybody know what allows me to do that? Sine is odd. So if you have a negative inside of a sine function, you can pull it out in front of the function and then no longer have a negative inside. Now, if you didn't do that on a test, I definitely wouldn't count you wrong. Cosine, cosine plus sine, sine. Who's that? Good. That's cosine of A minus B. So for us, that would be, ew, fractions. All right, pi over 3 minus pi over 4, which, y'all, you did go to 4th, 5th grade already. So can you common denominator that, baby? That'd be like 4 pi over 12 minus 3 pi over 12, better known as cosine of pi over 12. There you go. Isn't it funny how 5th grade math still makes you freak out? Yes. To this day, it does not change. Now, these 3 questions, and we have a minute or so. This is what was on Friday's homework. So I want you to expand it and then evaluate it. We're going to eventually use these as verifying identities on your test, right? So cosine of A plus B expands into cosine minus sine sine. And then you go visit your unit circle to simplify these. Cosine at pi over 2 is something pretty. Sine at pi over 2 is something pretty. What's cosine at pi over 2? It's just 0. And then sine at pi over 2 is 1. So think about what this really says, guys. This says 0 minus sine times 1. Y'all, we got minus sine. So what you're going to be doing for me on your test is verifying a trig identity using these expansions, okay? I'm going to leave these last 2 for you to finish. You're almost there, guys. We almost made it. Probably I kept talking. If I didn't have that first quadrant moment, we would have totally made it, right? The other part of your homework, please remember, is that short book assignment, page 352. All right, good luck.